So today's topic is differential amplifier. Here we have an operational amplifier. The input here is Vx, here it is Vy. Here we have R1, this is feedback resistor Rf, and here we take the output Vout. Here we have R2 and R3. Since the input impedance of the operational amplifier is infinity, no current will flow here. Therefore, I4, this current is I4, I4 is equal to Vy divided by, these two are in series, so R2 plus R3. Now what is V1? This is I4 multiplied by R3. So V1 is I4 into R3. So V1 is I4 Vy by R2 plus R3 into R3. Now since this is V1, this point is also V1 because the input impedance of the operational amplifier is infinity. Therefore, if this is going to be V1 with respect to ground, this is also V1. Therefore, we can write V2 is equal to V1. Now, I1 is the current flowing here. So, this point with respect to ground, this point is at Vx and this point is at V1. So, therefore, I1 is equal to Vx minus V1 is the voltage drop here divided by R1. Now, what is I2? I2, this point is V1, this point is Vout. So, current is flowing this way. Therefore, the voltage drop here is V1 minus Vout divided by Rf. That is I1 finished. Now I2 is V1 minus Vout by Rf. But you know that the current flowing into the op amp is 0. Therefore, I1 should be equal to I2. I2 is equal to I1. Now what is I1? So in the place of I2 I can write I1. I1 is equal to V1 minus Vout by Rf. So this I2 is replaced with I1. Now what is I1? I1 is Vx minus V1 by R1. You substitute here, which is equal to V1 minus Vout by Rf. So the next step will be, this can be written as Vx by R1 minus V1 by R1 is equal to V1 by Rf minus V0 by Rf. So that's what is written here. Left hand side will be same. That is Vx by R1. You move this negative term this side and move this negative term to the other side. So therefore this will become Vx by R1 plus V0 by Rf, which is equal to V1 by Rf plus V1 by R1. Now here the common term is V1. So therefore inside the bracket we have 1 by Rf plus 1 by R1. Now what is V1? V1 just now we have seen here. From this relation, V1 is Vy by R2 plus R3 into R3. That's what is written here. So V1 is Vy into R3 by R2 plus R3 into 1 by Rf plus 1 by R1. This is from equation 1. So here if you see, this is comes all along. So V0 by Rf, move this Vx by R1 to the other side. So you will be getting minus Vx by R1. Now Vout, multiply throughout by this equation, you multiply it by Rf. Therefore Vout is equal to Vy into R3 Rf by R2 plus R3 into 1 by Rf plus 1 by R1 minus Rf by R1 into Vx. Now what next step, what you do, you move this Rf inside. So Rf by R5, Rf will be 1 plus move Rf into 1 is Rf by R1. This is the required final equation for the output. So if you make all the values, that is R1, R2, R3 and Rf to be equal to R, then what will happen, that we will see. Okay, suppose if R is equal to R1, which is equal to Rf, which is equal to R2 is equal to R3, then equation 2, the previous equation becomes V0 is equal to Vy into R by 2R into 1 plus R by R minus R by R Vx. So on simplification, you will be seeing that Vout is equal to Vy by 2, RR gets cancelled, here also gets cancelled 1 plus 1 is 2. This 2 and this 2 gets cancelled, here RR gets cancelled minus Vx. Therefore, Vout is equal to Vy minus Vx. Therefore, the given circuit acts as a differential amplifier. This final result happens only because R1 is equal to Rf is equal to R2 is equal to R3 and all have the same values. I am calling it as R. Hope you have understood this topic on differential amplifier. Thanks for watching this video. Nandri.